Example 16 talks about force. And before we work it out, we need to understand that a force applied to a particle has both magnitude and direction. And therefore, force is also a vector. And the force causes the particle to accelerate. And from before, we know that force is equals to mass times acceleration. Mass of the particle multiplied by acceleration. Example 16, a constant force of F newtons acts on a particle of mass 2 kg. So M is equals to 2 kg. For 10 seconds, so T is 10 seconds. For 10 seconds, the particle is initially at rest, so U is 0, initially at rest, so the particle is not moving. And 10 seconds later, it has a velocity of 10I minus 24J. So V is 10I minus 24J meters per second. So we have everything. And then the question is asking us find F. Find F. Now, we don't have F, we have the mass, we have the T, we have the initial velocity, and we have the final velocity. So what don't we have? Of course, we don't have the acceleration. So from the arrangement V is equals to U plus AT, we have to say 10I minus 24J is going to be equals to 0, which is U, plus AT, or we have to have the T is 10 seconds. We have 10A. At this particular point, it is very clear that 10A, which is, this is the acceleration, this is the time, is 10I minus 24J. So if you divide everything by 10, everything by 10, we'll find that acceleration is I minus 2.4J. That is our acceleration, meters per second squared. But the question is not asking us to find acceleration. It's just part of what will help us to find the force. Here we can just talk about, but force is equals to ma as elaborated before. So we are looking for force is equals to what is the mass? What is the mass of the particle? 2 kg. So 2 times what? The acceleration, I minus 2.4 J. Now, the force eventually is going to be 2I minus 4.8 J. Of course, this is newtons. And at that point, we can confidently say that we have gone through all the processes and we have acquired our force, and that is it. All right?